These are video notes to the handout that was given out on 5.2 and 5.3. So for example 1a, in this case, we can say that it is not a polynomial since the exponents in this polynomial, so you can see the variable, this is a variable and there's the exponent. We have the variable, there's the exponent, and again this is the other variable with the exponent. This one actually is not a whole number, so this is not considered to be a polynomial. For the second example, this one is a polynomial because again this has the exponent of 2, this one has an exponent of 1, and this one has an exponent of 4. In terms of the degree, we're looking for the highest exponent next to the variable. So in this case, this is considered a fourth degree function. In terms of type, this one will be considered a fourth degree function because we do have a name for a first degree polynomial. We call it linear. If it was a degree of 2, then we would say quadratic. Degree of 3 would be cubic. Anything after that, usually we just take the number in the corner and just call it that kind of that degree polynomial. For the leading coefficient, it is always with the degree. So again, the degree in this case is the 4. So the coefficient for that one happens to be a 9. So for this example, what we want to do is actually combine like terms. If you notice, there's a subtraction in the middle, which tells you that you must distribute first the negative to the second terms that are in there. So using distributive property, first we'll go ahead and multiply -1 to the first one, then -1 to the second one, and then -1 to the third term. So we get something that looks like this. And then from here, what we want to do is go ahead and combine the like terms. So if we start off with 8t, 8t actually is a like term on its own, so we'll just write 8t here. We go with the 6. 6 is a like term with -7, so combine those, that gives us -1. A -5t squared and plus 3t is also like terms, so we'll go ahead and combine those. And then looking at the next one, there's no term to combine that one with. And from here, we like to put things in descending order for the most part, meaning that we like to take a look at the exponent of the variable here and then put them in descending order. So we start from the highest basically to the lowest. And so for the final answer, we do get -2t to the third minus 2t squared plus 8t minus 1. So for this one's just asking us to add. So we can ignore the parentheses, so it might be easier if we go ahead and write it without the parentheses. And then again, just like the last problem, all we're doing here is combining like term. So 4p squared would go with 8p squared. The -6p would go with the -7p. The 6 and the 4 would go together. And you have 12p squared minus 13p minus 2. Now for this one, we have to understand that they want us to multiply this binomial with this trinomial. So all we're going to use is basically the simple properties of distributive. So we will go ahead and take the first term in the binomial here and multiply it with the first term in the trinomial. Then we're going to do the first term in the binomial to the second term in the trinomial, and then the first term in the binomial to the last term in the trinomial, so that all of the terms in the second one, second parentheses, gets multiplied to the first term. So it would be something like this. We'll take the first one times the first one, so 6x to the third. If you remember with your properties of exponents, x to the first times x squared tells you just add the exponent, so you get x to the third. Then the next one is going to be x times 3x, which gives you positive 3x squared. Then we do x times -5, which is -5x. And then we go ahead and start with the second term and multiply everything with that term in the second, in the trinomial that's there. So this would be -2 times -6x squared, which is -12x squared. Then we take -2 times positive 3x, which gives you -6x. and then negative 2 times negative 5, which will give you positive 10. And again, just like the last two problems, we are now just going to go ahead and combine like terms. So again, 6x to the third is just 6x to the third. The next one goes with the negative 12x squared. Then we looked at the 5x, which you can combine with 6x. And then 10 is just 10. So this would be your final answer. Now with this one, they're asking us to multiply 1, 2, 3 binomials. So just like any other multiplication problem, we just multiply 2 at a time. So we'll go ahead and just take these two here first and then multiply that out by using FOIL. So if you remember FOIL, it's the first one times the first one, the second one times the second, inside. So the first terms, the outside, the inside terms, and the last terms, and that will give you negative 18. And we'll go ahead and simplify that piece right there. Now remember, x plus 5 we haven't really used yet, so we'll just go ahead and leave that to the side. But simplifying the first set, you get x squared minus 3x minus 18. And then now, this looks very similar to the last problem that we did, and again, we're going to go ahead and distribute here, except in this case, we're going to take this trinomial and multiply it with the binomial, but pretty much everything in the first part of the parentheses must be multiplied with every term in the second part of the parentheses. So again, we'll take x squared times x, then we'll take x squared times 5. We'll go ahead then start off with 3x times x, which gives you 3x squared. Then the 3x times 5, negative 3x times 5, which is negative 15x. Then we do negative 18 times x, and then we'll do negative 18 times positive 5. And then again, we're just going to go ahead and combine like terms. So x to the third is the only one, so we'll write that down. 5x squared can be combined with negative 3x squared. Negative 15x can be combined with negative 18x. And negative 90 is the only term that's similar, so that would be your final answer. So for this next one, if we take a look at what it really says here, they're asking us to basically take this term and multiply it to itself twice. So we can rewrite this as 6q minus 3r times 6q minus 3r, and we can go ahead and use the FOIL method or distributive method. So let's go ahead and go backwards here. We can go ahead and use that method and FOIL this thing, so we get something that looks like this. Okay, and we go ahead and combine the two terms in the middle. So this one will give us 36q squared minus 36qr plus 9r squared. So that's one way to approach this problem. But if you notice, this problem also can be used with a little bit of a shortcut. So if we take a look at this problem, there's a pattern for a binomial squared that gives you a perfect square trinomial. So the pattern is we take the first term and square that term. Then we would take the first term times the second term times 2, because if you notice, there's always two of these guys in the middle. And then to get this last term here, if you notice, all we did was take this last term and squared that term. So if we go ahead and fix each one of these up, you notice that we get the same answer as if we actually distribute or use a FOIL method, but either method will work. Now for this last one, we could write this out again as 2m plus 5 times 2m plus 5 times 2m plus 5. And again, like the other problems, we take the first two binomial, multiply that out. And then we take the result of that and then multiply it to the third binomial. So we get something that looks like this. And we go ahead and combine like terms. So we get 8m to the third plus 60m squared plus 150m plus 125. But there is a formula for this that eventually we'll look at patterns of these kinds of binomial to any power. It is related to the binomial theorem. It is also related to combinations and probabilities. But if you prefer to memorize the formula, what this tells you is that you basically take this first term here and you're going to you're going to cube it. Let me go back here. You want to cube that. The second pattern is we're going to go ahead and take 3 times the first term squared. So what it does is that this goes down by 1 exponent. And then there's a rule where the second term actually adds up. The exponent to the second one is to the first, and it adds up to 3. Then we go ahead and again write 3 again, and then the next term we're going to write 2m again, but only to the first power. And then the second term we're going to take it to the second power. And then for the last one, we're going to take that to the third power. And again, this is if you decide to memorize the formula that's on the worksheet. But you can see here, you can do the same thing as well, just writing it out 3 times as a binomial and then using the traditional distributive properties. But again, if we go ahead and fix each one of these, the first one here, basically we would write as 2m times 2m times 2m. That gives you 8m to the cube. For the second one, you want to fix this at 3 times 2m times 2m times 5, which gives you 60m squared. For the next one, it's 3 times 2m times 5, which is also the same as 150m. And then the last one just basically says 5 times 5 times 5, or it's 125. And you can see that it does give you the same answer as if you traditionally multiplied it out using distributive property.